Now we are going to learn about refraction of white light through a glass prism. So a prism is it's a solid which is made up of 3 rectangular faces and 2 triangular faces. In the front and in the back, it will be a triangle, and in the sides, it will be a rectangle. So this is what this is the dimension of a prism, dimensions of a prism. So when we send white light through a prism, what happens? That process is called as dispersion. So as we all know, white light is made up of 7 constituent colors, which are violet, indigo, blue, green, yellow, orange, and red, abbreviated as WIBGR, that is the acronym. So now when we send white light through a prism, what happens? As you can see in the diagram, they are sending a beam of white light from the left side, which can either be sunlight or some light from a bulb. So when we send white light, then as soon as it enters the surface of the prism, as soon as it hits, it splits into 7 different colors. And those 7 colors together is called a spectrum. All the 7 colors put together is called a spectrum. So this is something that we need to know. The band of 7 colors is called a spectrum. So this we need to understand. The band of 7 colors that white light splits into is called a spectrum. And this process is called dispersion. Dispersion is the process of splitting of white light into its constituent colors. So the 7 colors have always been inside white light, but when it passes through glass or glass prism, it would have split into 7 colors, and that process called as dispersion, the splitting of white light into its constituent colors. Now, after splitting, you can see it has been split into 7 colors, and this looks like a rainbow. So some of you would have seen this when we just view a tube light through a glass scale, glass ruler. When we just view the tube light, we can see some rainbow formation kind of happening in that. So this is dispersion and this is spectrum. Now, if you observe the pattern in which they are split, we can see the red color has undergone the least deviation. So this is red color. So it has almost gone straight line. If you see, there has been a bend here. I mean, if you continue drawing this incident light, it will go like this. The beam of white light, if it continues without the prism, it will go straight. And you can see all of the colors have deviated through different angles. They have deviated through different angles. So now after splitting, you can see red color has been bent the least. It's almost straight line. So it undergoes the least deviation, and the deviation increases as we go downwards, and violet undergoes the maximum deviation, as you can see here. So when we say deviation, deviation from what? If you continue this line, incident light, if you continue this will be the line. And from here, to what angle is the red color deviated? To what angle is the orange color deviated? To what color is the yellow? So this is what we call it as deviation. And we can clearly see as we keep going down, the angle of deviation is also more. This is something that we need to know. But in the first place, why does it deviate? Or why does it bend in this place? That is because of refraction. Because in this interface is the separation of 2 media. So here we have air, and inside this we have glass. So when light is traveling from air to glass, there's a change in medium because of which refraction happens. And what we call as refraction here is the bending of white light. Now what happens? White light is no more going in the same straight line. Since there is a change in media, it will bend. And how will it bend depends on type of media it is traveling from and type of medium that is getting into. So as we all know, air is the rarer medium and glass is the denser medium. So the white light after bending, it will bend towards the normal, and that is what is happening. So if we keenly observe here, the normal that we draw here is somewhat like this. We need to draw it like this. So the normal should always be perpendicular to the interface. Interface is the separation. So this is the separation. The maroon color is the separation. And at 90 degrees to which we draw the normal. So now when you see, the incident ray is not going straight. it has been bent towards the normal. You can see all the light rays are bending towards the normal, and that is because the light rays are traveling from a rarer medium to a denser medium. This is about this interface. Again, at this interface also, at the second interface also, there's a change from glass to air. And if you see, you can draw a normal. For each of the colors, we can keep drawing normals. But I would like to explain with respect to any of the color, maybe green. And now you can see, since as it is traveling from glass to air, it is going away from the normal. And that is because light is traveling from glass to air, which is the denser medium to a rarer medium. So this is very important. Again, there is a bend. Here also there is a bending. Here also there is a bending. And that's how we get all the 7 colors, and it's called the Webjur. So this process is called as dispersion. This is something that we need to understand. So I hope it's quite clear. So what happens in this interface? Air glass interface is a refraction, because of which light is bending. Again, at this interface also there is a refraction because it's going from glass to air. So there is 2 refraction that's happening, and in the process, because of the material of the medium, because of glass, the white light is also getting split into 7 colors. Now, why the 7 colors are showing different deviation? Why are they not in the same path? Why are they taking different path? That is because each of the color will have its own wavelength. Wavelength is something we have learned in grade 9 and 8 and all that. I would like to revisit what is meant by wavelength. So light will travel in the form of waves like this. Now, when it travels like this, there are going to be peaks and there are going to be valleys also. You can see these are the peaks and these are the valleys. And the distance between 2 consecutive peaks or the distance between 2 consecutive valleys is called wavelength. Or it can also be shown like this. One complete cycle starting from here till here. So this is called one wavelength. Or this can also be told as this distance, or the distance between the peaks, or the distance between the valleys. All 3 are going to be the same. They are going to be equal. So we can call it either ways, the distance between 2 peaks or 2 valleys, or from the starting point of a cycle to the ending point of a cycle. So this is called one cycle or one oscillation. This length is called wavelength, and this is called one cycle or one oscillation. So now there is one more word we need to know before getting into the concept, which is called as frequency. And frequency means which within a second, within a unit time, how many cycles are formed. Here you can see 1, 2, 3. So the frequency is 3. So we need to understand these basics before getting into the concept. So now, why is red least deviated? Is because it has a longer wavelength and a shorter frequency. This is something that we need to know. Longer wavelength and shorter frequency, whereas blue and violet are getting deviated the most because they have short wavelength and longer frequency, larger frequency maybe. This is something that we need to understand. So each color will have a specific wavelength, and if the wavelength is too short, then it can get deviated the most. And if the wavelength is too long, then it undergoes less deviation. And that goes hand in hand with frequency also. Shorter wavelength means there is larger frequency, and longer wavelength means there is shorter frequency. This is something that we need to know. So we just saw how dispersion happens in a glass prism. We send white light, it undergoes refraction, again it undergoes refraction. In the process, it splits into 7 colors. The band of 7 colors is called a spectrum. And you kind of understood why they are getting split into 7 colors, why they are bending at different angles. That is because each color will have a different wavelength, and the ones that have short wavelength will be bending the most, which is blue color, and the ones that have longer wavelength will bend the least or will get deviated the least, and that's called as red color. Now, to understand some diagrammatic parameters that we use, we are going to look at this diagram. So you can see this is the incident beam, which means this is the light, or this is the white light that will be sending in. And now at the surface, they have clearly given the normal. So you can see normal is something that is imaginary. That is why they have given dotted line. And that's also perpendicular to the interface. Now, what do we call as interface? It is the separation, line of separation between the two media, which is air and glass. Now, as it keeps, so as the light ray enters, since it is entering from a rarer to denser medium, it is bending towards the normal. We can see here. This is bending towards the normal. And finally, again, it is bending away from the normal. We can see. So this is the path of the light ray. There is incident beam, and this middle one is called as the refracted beam. And the last one is called as the emergent beam. It's called emergent because it finally comes out, emerges out of the glass prism. So this is something that we need to know. Incident beam, refracted beam, which has not been mentioned here, and also emergent beam. In the due course, in this gap, it will get split into 7 colors, and they have given only one of the colors to make the diagram a bit simpler. They have shown only one line to make the diagram a bit simpler. Now, we know there are 2 normals for the 2 interfaces. This is one interface, and you can see one normal. And there is another interface, and we can see one more normal also. Now, the angle between the incident ray and the normal is called as angle of incidence. Angle between normal and the emergent ray is called as angle of emergence. Angle between the normal and the refracted ray in both the sides are called angle of refraction. So this is something that we need to know. Also, every prism will have some angle at the top, at the apex. Apex in the sense that at the top they will be having an angle. So that angle is called as angle of prism. And most importantly, if I extend the incident beam imaginarily, you can see they have extended here. You can see this extension. This is the imaginary extension of incident beam. And if you extend the emergent beam in the reverse direction, I'm using green color for better understanding. If you extend the incident ray, you can see like this. I'm extending the incident ray. It cannot be done, but imaginarily we are extending. And we are extending the emergent ray in the backward direction. There is an angle that is formed in between them. You can see this blue color angle, and that angle is called as angle of deviation, which shows to what extent has the ray been bent or deviated from the original thing. If the glass prism was there, this will continue in this direction. But as compared to the original intended direction, how much has it gotten bent or deviated? That is called as angle of deviation. This is something that we need to know. And this summarizes all the parameters that we use in this. And what are the factors on which this angle of deviation depends is also very important. So this angle, that is the angle of deviation, depends on a few factors. One is the material of the glass. What material is the glass prism made up of? There are types of glass also, whether it is very hardened glass or it's quartz glass or whatever like that. We have different types of glass. So that is based on the material and also based on the light that is being bent. For example, if it is blue color, the deviation will be too much. So it also depends on the color of light and also on based on the material. So based on all this, we have an expression which goes like this. So this is a very important relation between angle of incidence, angle of emergence, and angle of refraction. As you can see on the diagram, angle of incidence and emergence will be the same. Whereas refraction will be smaller. It will be smaller because it's going from a rarer medium to a denser medium. So angle of incidence and angle of emergence are equal in most of the cases, but that value is greater than the angle of refraction. So basically, I can write like this: angle of incidence and angle of emergence are equal, but both of them are greater than the angle of refraction. So this is a thing that you need to understand. So we just saw white light can be split into 7 constituent colors in the process called as dispersion. Is it possible to reverse this phenomenon? Yes, if we place an inverted prism next to it. Like you can see, if we place one prism and the inverted one next to it, you can see again it recombines to form white light. Now some of you may be sitting with the doubt, what happens if I place a normal prism here instead of an inverted prism? So already there is a deviation. Again, there will be deviation. It will go somewhere down. You will not be even able to capture it. So that is why we use an inverted prism, wherein again there is deviation and you will be able to get the white light. And mostly the incident white light here and the emergent white light will be parallel to each other. And why this is happening is again the same logic. So here you can see there is air, glass. Here there is air, glass, and air. So what happens here is, and here this is the normal. So what happens at this interfaces, there is also again bending of light towards the normal, you can see. And again here there will be bending of light away from the normal. So these are all the reasons, the very same logic recombination happens. And this was found by Sir Isaac Newton. And so the question will be, in the examination will be like, how do we get white light back after dispersion? By just placing an inverted prism next to it, we can get the white light. This is also something important that we need to know. So we saw how dispersion happens in glass prism. So how white light is getting split into 7 constituent colors and how it can be recombined again to get white light. The next topic that we're going to see is called rainbow formation. Rainbow formation is also a phenomenon which is based on refraction and all of that. So this is a diagram which kind of explains how rainbow is formed. So you can see there is there are 4 steps in rainbow formation. The first step is refraction. The second step is dispersion. The third step is total internal reflection. And the fourth step is again refraction. This sequence is very important from examination point of view when it comes to CBSE exams. So the sequence is very important. All the 4 steps I would like to highlight using some boxes. You can see refraction is the first step, dispersion is the second step, total internal reflection is the third step, and refraction again is the fourth step. So these 4 steps will contribute towards how a rainbow is formed. Let me try to explain this. So the light that is coming from the sun, that is the white light. So what you're able to see here is a water droplet. This is just a water droplet. That's a raindrop basically. So when you know rainbow is formed around this rainy time, whenever there is a rain, especially after the downpour, you will be able to observe rainbow. So there are tiny droplets, raindrops. Now what happens is there is a light that is coming from the sun. As soon as it hits this surface, the point B, there is a change in medium from air to water because the drop is made up of water. So this is made up of water, this is made up of air, because of which there is a change in medium. Now all these tiny drops will behave like prisms. They will behave like prisms, and that is what is happening here. So they will be behaving like prisms. And at this point B, there is a change in medium from air to water. Now when there is a change in medium, it will tend to bend towards the normal, and that is because air is a rarer medium, it is lighter, thinner, and water is a thicker and denser medium. So it will bend towards the normal. You can see it is bending towards. And what I mean by normal is the perpendicular to the surface of this drop. And it is bending towards the, you can see this, it is bending towards the normal. So this is the normal. Let me draw with black color. So this is the normal, and you can see it has bent towards the normal. Instead of going straight like this, it has been bent towards the normal. And during this process, since the water droplet behaves like a prism, it will be able to scatter the white light into 7 constituent colors, and that process is called as dispersion. So step 1 is refraction, because there is a change in medium. Refraction always goes hand in hand with the phrase change in medium, and because of it, it splits into 7 colors. That splitting of 7 colors is called as dispersion. And at the other surface, it is getting total internal reflection. We should be very careful here. It is reflection and not refraction. Now, what we mean by total internal reflection is, so whatever the light that is going, instead of going to the other medium, that is, instead of going to air like this, they will be completely reflected like how a mirror will behave. See, imagine there is a mirror here. all the light will be reflected back. That process is called as total internal reflection. So the whole spectrum, when I say spectrum, all the 7 colors will be completely folded back, reflected back. And again, here there is again a change in medium from water to air, because of which light ray will be bending away from the normal. You can see here, and that is why we are able to see the band of 7 colors. Now, this will reach the human eye. And that is why we are able to see rainbow. And from the bottom, it is VIBGYOR. And that is because violet will be bent the most because that's the short wavelength, as we discussed in the previous case. And red will be deviated the most. And that is why it will be at the top. Now, some of us will be sitting with the question, why has it gotten totally internally reflected? Why not here itself it goes like this? That is because at a particular angle of incidence here. See, for example, if the light ray was coming from this direction, please observe brown color. If the light ray was coming from this direction, as soon as it hits the other surface, it may come out like this. It will not get totally internally reflected. But after a particular angle, that angle is called critical angle. All of that is not in grade 10. So after a particular angle, when it crosses a particular angle, then instead of getting refracted, it will get reflected. And that process is called as total internal reflection. So these 4 steps will contribute towards rainbow formation, and that's how we're able to see the rainbow. Now, the rainbow is not something that we get only from one raindrop. You can see here there are 2 droplets. They have given just 2, but it will be like numerous. Lot of various droplets will be there. So each of which will behave like a tiny prism, each of which will undergo these 4 steps, that is refraction, dispersion, total internal reflection, and refraction. And the combination of all of these is what we see as rainbow. For example, the red color is coming from this raindrop, but the blue color is coming from this raindrop. You can see clearly from the diagram. So the previous slide was just to show how a rainbow is formed, but in actuality, you have much more raindrops contributing towards a rainbow. So this is something that we need to